What is the actual number of planets in the solar system? If I were to ask you to picture our solar system, you would probably picture the large posters that we have been accustomed to viewing since we were young children, wondering about the secrets of the cosmos. You can imagine Saturn with its stunning rings, Jupiter with its orange and brownish colors and unique features on the planet, or Earth with its azure oceans. But what if I questioned you on the size of the solar system's planets? Of course, 8 would be the obvious response. Those posters are actually fairly clear. Mercury is followed by Neptune. However, it turns out that there are only 8 planets, and that is only because of the official definition of a planet that we employ. For instance, posters from before 2005 would depict the solar system as being formed by 9 planets rather than 8 because Pluto was still regarded as a planet at the time. It's absurd to consider how our perception of reality is altered by our understanding of the cosmos, which in turn alters the semantics we employ. If all objects in the solar system had nearly perfect triangular shapes, for instance, there would be no planets at all. Anyway, we were stating that there are only 8 planets in the solar system by definition. 3 principles can be used to describe a planet. 1, it should be heavy enough to have a sphere-shaped surface. In actuality, gravity pulls inwards toward the center of the body for items with a certain mass, and if the object is heavy enough, it will become spherical in shape because gravity works in all directions equally. A thing that isn't big enough to be a spherical can't be called a planet. There may be a gray zone in terms of mass where it is difficult to determine whether the thing we are confronting may be categorized as a planet in these words. This is because the variety of objects, masses, and shapes is kind of continuous in our universe. For instance, there might be certain objects that are strikingly similar to planets but have a little bit less mass than what is required by gravity to give it the required spherical shape. So, to put it simply, if there is an object that orbits the Sun but is not massive enough to have a spherical shape, I'm sorry to say that it cannot be categorized as a planet. The second rule is that a body must be in orbit around the Sun in order to qualify as a planet. 2. Although we are obviously referring to the solar system as a whole, any object that revolves around its star is considered to be a planet. However, in this instance, we would not be discussing planets, but rather exoplanets, such as those that have been investigated and found by the Kepler mission. As you can see, our solar system's 8 planets are the only actual planets. 3. The planet must rule its vicinity as the third condition. It should essentially be the largest object along its own orbit, but the situation is more complicated than that. For instance, Pluto does not meet this last criterion because, at some point during its orbit, it crosses Neptune's orbit, making it no longer the primary object controlling its own orbit. All matter is subject to physics rules and orbits. And if this aggravates you, talk to the police of celestial mechanics. The worst part of this concept is that if you took Earth and put it where Pluto is, the same thing would happen. Earth would also cross Neptune's orbit, losing its exclusive position as a planet. In general, this third condition appears a little odd because it is more location-based and focused on the position of that particular thing rather than on what the object is. Determining the relative positions and functions of the solar system's objects can be helpful on the one hand, but it can also be useful on the other because a different definition, perhaps a geological definition, might be the wrong one because we would have to exclude all the planets that don't fit that particular geological definition. Just to mention it, we could consider eliminating the second rule and defining a planet as an object with sufficient mass to be spherical. However, this would include stars as well, so we must modify it to read, a planet is an object with sufficient mass to be spherical, but not sufficient mass to initiate nuclear fusion in its nucleus. At that point, we may also assert that objects with a tail are comets, objects with a potato-like appearance are asteroids, etc. This is a greatly condensed version of the definition. In this condensed definition, planets are defined as bodies that are sufficiently massive to be spherical but not sufficiently big to shine due to nuclear fusion. The second rule, which states that planets orbit the Sun, may then be added if we so desired. If we use this definition, our solar system would consist of 13 planets. In fact, we would need to discover 5 more in addition to the existing 8: Pluto, Ceres, Makemake, Haumea, and Eris. These fall under the category of dwarf planets. As you can see, a small change in the definitions or semantics might have a profound effect on how we perceive the universe, and our posters would be significantly altered. Hey! You must have a deep curiosity about planets and dwarf planets if you are still here watching the movie. Be sure to subscribe immediately and turn on the bell notification, since we continually work to create videos that pique the interest of viewers like you. The number of dwarf planets in our solar system is unknown, though. How many of them are there in reality? It's complicated. There are plenty here. We have observed these objects, but because they are far farther away than Pluto, our knowledge of them is quite limited. We are aware that their size can range from 400 to 1,000 kilometers in radius, and if they are made of stony ice and water, as we believe given their great distance from the Sun, their mass should be sufficient to give them a spherical shape. In this scenario, our solar system would contain a large number of dwarf planets that are only waiting for us to identify them more thoroughly and include them in our posters. Examples of some of these are Gong, Orcus, and Sedna. We could get additional information about them from brand new space observatories like the JWST before the end of this decade, which would improve our understanding of the cosmos we currently inhabit. Of course, the potential existence of Planet 9 should also be considered. Some minor objects' paths were found to have some deviations, which indicates that an unidentified perturber is influencing their orbits. The measured statistics indicate that this perturber would be extremely far away in the interstellar region and would weigh between 6 and 10 Earth masses. Therefore, if such a planet exists, we would observe it as a very faint source that is orbiting the Sun along an orbit with a very large semi-major axis. Planet 9's probable origins have been investigated, including in situ formation, capture from another star, and ejection from the vicinity of the known big planets. A close collision with Jupiter or Saturn during the nebular epoch would have caused Planet 9 to be flung into a faraway eccentric orbit, according to the theory put out by scientists Badigian and Brown in their initial article. Its perihelion expanded due to a nearby star's gravity or the pull of the gaseous solar nebula, placing it in an extremely wide yet stable orbit outside the reach of the other planets. The likelihood of this happening has been calculated to be a small percentage. Planet 9 may have gathered more mass from the protoplanetary disk and evolved into the core of a gas giant if it hadn't been hurled into the furthest limits of the solar system. As a result, it has a lesser mass than Uranus or Neptune because its expansion was prematurely stopped. Or perhaps a close encounter between the Sun and another star allowed Planet 9 to be taken from beyond the solar system. Three-body interactions during the encounter may change the planet's path, leaving it in a stable orbit around the Sun if it were in a distant orbit around this star. A planet that formed in a system devoid of planets with the mass of Jupiter may stay in a far-off orbit for a longer period of time, increasing the likelihood that it will be captured. The odds of the Sun catching Planet 9 rise by a factor of 20 if the Sun ever had a distant, equal-mass binary companion, according to astronomers Amir Siraj and Avi Loeb. So perhaps we should search for an elderly Sun mate who is disinterested. It is quite challenging to see because it is so far away and dark. Because Webb is built to examine things with known positions in the cosmos, but we don't actually know where Planet 9 could be in space. Even JWST would have difficulty searching for it. It would be like using a magnifying glass to search your home for your smartphone. If you could only rely on your own eyes, it would be far better and less time-consuming. I wish you luck in that. In any event, I would draw attention to the fact that we would be missing out if we relied solely on the definition of a planet as a body orbiting a star. What if I told you, for instance, that there are large, spherical objects that could support life and have seas on their surfaces but are not in orbit around any stars? It is possible that a moon of Saturn, Titan, which is similar to Earth but is based on methane rather than water and has its own hydrologic cycle, could be categorized as a planet. The definition of a planet in this context would be any object large enough to be spherical and that orbits another planet. We can refer to them as solar planets if they revolve around the Sun, satellite planets if they orbit another planet or object, and exoplanets if they revolve around another star. In this scenario, the Moon would be considered a satellite planet and the solar system would have approximately 108 planets, as seen in our posters. As you can see, there is some debate over what constitutes a planet, and as soon as that definition changes, so does our understanding of the cosmos. The Greek concept would be ideal if we could travel in time and adopt it. It would be a lot simpler. Actually, the Greeks believed that every object moving in the night sky, aside from comets, was a planet. The only issue is that there are many artificial satellites in our nighttime sky that orbit and move. At that point, should we still talk about them as planets? Thank you everybody for watching. What do you think of this video, guys? Please let me know in the comments section below. Don't forget to subscribe, and I'll see you on the channel again soon.